Hello everyone, and thank you for your watching first. And in this video we are going to solve this equation, a log equation with infinite terms. And first of all, I would like to emphasize the difference between the numerator, the log x squared, and the denominator, the bracket log x whole square. So what is the difference of these two terms? I think many students are confused about this. And for the first one, we know that if there's no bracket around the log x, this square belongs to x only. So we can write it like this. We put a bracket around the x square. And of course, the 2 can go to the front as a constant by the property of log. And for the right hand side, this one we cannot do any simplification at time being, and you can plug in some numerical value to have a comparison, like log 10 square and bracket log 10 whole square. And the first one is equal to 2 log 10, which is 2, and the second one is the 1 whole square, which is 1. So they are different. Okay, then we need to solve this equation. As you can see, the power of each term is increasing, and of course the numerator and the denominator are different. So we try to simplify the equation a bit first. Notice that the numerator, the power can go to the front as a constant. So we put all the constant at the front first. So the first one is 2 log x over log x whole square plus 3 log x over log x whole cube plus ... Similarly for the third term, and it's equal to 8. So now we can cancel out a common factor here. We can cancel out, so the power of the denominator will reduce by 1. So the first one is 2 over log x, second one is 3 over log x whole square, and the third term is 4 over log x to the power of 3 plus ... and it's equal to 8. So how can we proceed? Notice that this series is neither a arithmetic series or a geometric series. We notice that the constant term is increasing, right? It will be very nice if we can make the left hand side of the equation, the numerator, to become the same. For example, if we can make it become 2 over log x plus 2 over log x whole square plus 2 over log x whole cube plus ... Then this equation, this series is a geometric series, so we can apply some formula to simplify the terms. So how can we proceed? So let me erase it, and then I will call this equation to be 1. So how about we multiply both sides by 1 over log x? So we try to multiply both sides by 1 over log x right here, and then I copy the equation again, plus 4 over log x cube, and then the right hand side will become 8 over log x, and then this 1 over log x will go into the bracket, and then the left hand side will become 2 over log x whole square plus 3 over log x cube plus 4 over log x to the power 4 plus dot dot dot. And then we call this new equation to be number 2. Well, now we can focus on these two terms. This 3 over log x whole square and 2 over log x whole square. And then the second one is 4 over log x cubed. And then the 3 over log x cubed. We try to find the difference between these two equations. So I put 1 minus 2. So as you can see, if we minus the first one from the second one, we'll get 2 over log x. This term will remain here. And then the yellow term, the difference will become 1 over log x whole square plus the green term, the difference, okay, is also 1 over log x, this time whole cube. And then for the next term is 1 over log x to the power 4 plus dot dot dot. And then for the right hand side is x minus x over log x. So I write it on the right hand side like this. Okay, so now we can do more simplification now. Notice that this series is in fact a geometric series. This is very nice. So now we know that the first term is 1 over log x whole square, and the common ratio will be 1 over log x, right? So now we can apply the formula for the sum of infinite geometric sequence, which is a over 1 minus r. So we can simplify the left hand side further. The first term is 2 over log x plus a, which is 1 over log x whole square, over 1 minus the common ratio 1 over log x, and it's equal to the right hand side x minus x over log x. So but we need to pay attention to the range of r. So we know that r should lie between -1 and 1. So this make 1 over log x lie between -1 and 1. So now okay, there are so many log x in different positions. So how about we let another constant y equal log x. So now we have 2 over y plus 1 over y square over 1 minus 1 over y, and then equal x minus x over y. So this is okay, more simplified. And then we do some algebra work. We put the numerator, the whole fraction in the front, multiply. Notice that this one will become y minus 1 over y, and then we flip the fraction, so we get y over y minus 1 equals how about we factorize the x out, and then we make the two terms to become a single fraction, y minus 1 over y. So these two y will cancel out, and then we know that in the denominator there are y here, so we multiply both sides by y in order to cancel out the denominator. So I will go to the right hand side to do the remaining work. So now the first term is 2 plus 1 over y minus 1 equal x times bracket y minus 1. So now we multiply both sides by y minus 1, and the left hand side becomes like this, and then the right hand side becomes x times y minus 1 whole square. And then we'll expand and simplify each term. Left hand side like this, and then the right hand side will become y squared minus 2y plus 1. So now the left hand side is 2y minus 1 equals xy squared minus 16y plus 8. We put all the terms on the right hand side, so the left hand side become 0. The right hand side have xy squared minus 18y plus 9. So we can do some cross method factorization on this. So how about we split the term like 2y and 4y, and then for the 9 we do 3 and 3, then we cross multiply them. The first one is 6y and the second one is 12y, and we want a negative sign here, so we add negative on both 3. So the factors are 2y minus 3 multiplied by 4y minus 3. So the y will become 3 over 2 or 3 over 4. So what is y? Y is log x, right? So log x will become 3 over 2 or 3 over 4. So remember our range of 1 over log x should lie between minus 1 and 1. So now I flip over the left hand side 1 over log x. So the fraction will become 2 over 3 or 4 over 3. So we will reject the second solution. So now we only concerned about the first one, and then we know that x will equal to 10 to the power of 3 over 2. So this is the final answer. And I hope you guys will like this video, and please like my videos, and if you would like to, please subscribe to my channel. So I will see you in the next video. Bye bye.